So in this video, we're going to look at the aircraft head-up display once again, specifically this HUD horizon line that you can see here with the sun clearly below. And also in a previous video, I showed the moon below this HUD horizon line. Now it seems that there are still flat earthers who fail to understand the significance of this and what this HUD horizon line is actually representing. But first, let's take a look at this question, which appeared on the AIN online website in 2016 as the Aviation Safety Question of the Week. And the question is, while at high cruise altitude in your head-up display equipped aircraft, you notice that the actual outside horizon is significantly below the HUD horizon line, the zero pitch reference line. What does this indicate? And the options are A, normal operations, B, optical illusions due to light refracting at high altitude, C, misalignment of HUD symbology, or D, HUD combiner not firmly in its flight detent. Have a think about that question and the answers, and we'll come back to it at the end of the video. Now, the reason my head-up display videos are so devastating to flat Earth is because they utterly destroy the claim that the horizon rises to eye level. This HUD horizon line is eye level, and as we can see in the footage, the sun is below eye level, and that means the Earth horizon is below eye level, and we see the same thing at night with the moon. The enhanced vision system in the aircraft is showing us that the Earth's horizon is well below the HUD horizon line, and we can clearly see the moon is below this eye level also. Let's take a look at what eye level means. Remember, the flat Earth claim is that the horizon rises to eye level. So what is eye level? We can look it up in several online dictionaries. Eye level, the level of the eyes looking straight ahead. Definition of eye level, a level that is as high as a person's eyes. If something is at eye level, it is positioned at approximately the same height as your eyes. The height of a person's eyes. Eye level, level with a person's eyes when looking straight ahead. So if my eyes are 175 centimeters above the ground when I'm standing, if I were to draw a mark on the wall at the opposite end of the room, I would have to position that at 175 centimeters also for it to be at eye level. So we can say that eye level is horizontal from the eyes. When we are looking horizontally, we are seeing eye level. So when we talk about eye level, we are talking about a direction that is horizontal from the pilot's eyes. And that is precisely what this HUD horizon line is showing us. It is showing us the direction of horizontal from the pilot's eyes. And I think this is where flat earthers get confused, because it will continue to always show horizontal regardless of the aircraft attitude. Here is a side profile of a pilot looking through a head-up display. We have what is called the eye box. Now, if our eyes are within this eye box, we can see the symbology through the HUD. If we move outside, we lose the symbology, and that is why it is important to set our seating position correctly before flight. Remember, eye level is always horizontal to the eyes. If the aircraft were to pitch up, this head-up display will move upwards with respect to horizontal. So horizontal will appear at a lower position in the head-up display. If the aircraft was pitching down, this head-up display moves down with respect to horizontal from the eyes, so the horizontal line would pass through the upper portion of the head-up display. Let's see if we can observe that in reality. So we're now going to look at two different scenarios and see where this HUD horizon line appears in the head-up display itself. Firstly, at 43,000 feet, maintaining a constant altitude. this HUD horizon line appears below the altitude pre-selector indication and below the airspeed selected indication. That is Mach 0.85 and that is 43,000 feet, and you can see the head-up display HUD horizon line appears below those two indications. Remember, eye level is always horizontal from the pilot's eyes, and eye level is what is being depicted by this HUD horizon line. Now, when the aircraft pitches down in a descent, eye level remains horizontal, and therefore the horizontal position indicated in the HUD will appear higher in the HUD because the HUD has dropped with respect to horizontal. And that is absolutely what we see here. We now have the aircraft in a descent, indicated by this waterline being below the true Earth horizon, and this HUD horizon line, which is representing eye level, horizontal from the eyes, is now above the altitude pre-selector indication and above the airspeed selector indication. So the aircraft being nose down means the head-up display itself has moved down with respect to horizontal from the pilot's eyes, and that is why we see this HUD horizon line, which is eye level, at a higher position in the head-up display. So for the majority of normal attitudes encountered during flight, horizontal from the pilot's eyes will pass through the head-up display, and that is what we will see with this HUD horizon line. However, there are situations where the aircraft attitude may be so great that horizontal from the pilot's eyes no longer passes through the head-up display. One scenario where this could occur is taking off at very light weights because the aircraft will be climbing with a high nose angle. When this occurs, the HUD horizon line will appear at the lower portion of the HUD, and if the nose attitude is so high that horizontal is below the HUD itself, the pilot gets an indication that the HUD horizon line is non-conformal because this line becomes dashed. Anytime the line is solid, we know that it is conformal and showing us accurately the position of horizontal, the position of eye level. When it is non-conformal, it means the display can no longer project horizontal through the head-up display. Let's look at that in an actual scenario. So here is some actual footage taken through a head-up display in a Global Express aircraft while it is taking off. You can see the HUD horizon line is at this portion in the head-up display. Now when the aircraft takes off and pitches up, you will see the HUD itself going up with respect to the external horizon, but you will see the HUD horizon line is remaining at horizontal at all times, and that means it will appear to move down in the HUD. If it moves so far down that it cannot be projected accurately, you will see it goes to a dashed state, which means it is non-conformal. Now it happens fairly quickly, so please watch carefully. You can see there that the HUD horizon line is now in a non-conformal state. It is dashed. When the aircraft attitude is lowered slightly, it becomes a solid line once again, meaning it is conformal. Anytime it is dashed, it is non-conformal, and there it is solid again. You can see as the aircraft is climbing, that HUD horizon line is getting higher and higher above the Earth horizon, because that HUD horizon line is always showing us horizontal from the pilot's eyes, regardless of the aircraft attitude. And this is why my videos showing the sun and the moon clearly below horizontal from the pilot's eyes, clearly below eye level, are so devastating to flat Earth. Not only do they destroy this claim that the horizon rises to eye level, but it would be physically impossible to have this on a flat Earth if the sun and the moon were circling above a flat Earth. At this altitude of 13,000 feet and this altitude of 43,000 feet, we would never see the moon or the sun below eye level, below horizontal from the pilot's eyes. And yet, that is precisely what we see in reality. And here is some additional footage taken through my head-up display the other day, just to prove once again that moving the camera up and down or tilting it will not change the position of this horizon line. It is simply showing you horizontal from the pilot's eyes, eye level. As you can see, it is going through the window of the aircraft on the other side of the tarmac. What I do in this video is I move the camera up and down, and you can see that HUD horizon line does not change position. I then also tilt the camera up and down, and once again the HUD horizon line always shows horizontal from the pilot's eyes. Now, some of you may have seen this footage already on Where's Wally's channel. He also did an excellent video on the topic. So I'll play this footage shortly. And this last clip was taken in Perth back in May, where I was doing basically the same thing, just moving the phone up and down to prove that the HUD horizon line does not change position. It is always showing horizontal from the pilot's eyes. Now, as luck would have it, we see a van drive into view on the left-hand side, and the top of that van is at eye level, so it appears in line with the HUD horizon line. As it continues to move away from us, it reduces in size due to perspective. However, because the road surface is flat, the top of that van always remains at eye level. So perspective alone does not cause objects to drop below eye level. And this is a good demonstration of that. So I'm sorry, flat earthers, you can rant and rage and obfuscate as much as you want, but it won't change the reality. And the reality is that here we see the moon below horizontal, below eye level, and here we see the sun below horizontal, below eye level, utterly destroying the flat earth claim that the horizon rises to eye level.